Okay, let us look at the page number 5. Okay, so do you have the notes? Yes, right. So can we look at page number 5? So in the beginning of this lesson, okay, maybe the first 30 minutes, we're gonna go through the empirical formula experiment once again, because the experiment for empirical formula MGO and CUO is like one of the question that for sure it will be coming out in your first term exam. So these are the things that you must know. So starting from page number 5, our MGO experiment. Okay, guys, for all the empirical formula experiment, they got one thing to do. Okay, they only have one thing to do, which is they carry out the experiment to get the mass. This is what they want. This is the result they want. They want to find out the mass of each substance so that they will be able to calculate the empirical formula. Okay, so to get the mass of what? If we are determining the empirical formula of magnesium oxide, then we will have to get the mass of magnesium and oxygen in that experiment. So if we change magnesium oxide to empirical formula of copper 2 oxide, we actually want to find the mass of copper and oxygen so that we can do a calculation like this at the bottom. Okay, where is it? I show you this one here, like this. Okay, so we can have different element. Okay, we can have mass, we can calculate number of mole, and the simplest ratio, things like that. Okay, can. So in this experiment, there are a few precautions that you have to remember. The precautions are, look at the bottom here. Before we start doing the experiment, we must clean our magnesium ribbon with a sandpaper. This is to remove the oxide layer on the surface of the magnesium ribbon. Okay, this is something I need you to remember. So I will go through things that we will be doing later. So these are the answers that you need to write later. Okay, so when the magnesium starts burning, it produces white fumes. The white fumes produced in the experiment is actually magnesium oxide. Okay, the difference between this experiment and the CUO experiment is this is the experiment for reactive metal. So only reactive metal can use this method. What is this method? Direct heating. We straight away heat the metal. Can you see? We heat the metal directly, and then the metal, okay, we heat metal directly, and then the metal starts to burn. Boom, okay? Only reactive metal can do this because when you hit it, it will starts to burn. If it is not reactive enough, if you hit it, nothing will happen. It's like iron. Let's say I get an iron nail and then I hit it with a lighter. Nothing will happen. Okay, they will just become hot. Okay. So when magnesium starts burning, it produces white fume, which are magnesium oxide. And then later on, when it starts to burn, we need to close the crucible lid. This is to prevent the white fumes of magnesium oxide from escaping into the air. When it starts burning, right, it produces MgO. We want to close it and make sure that MgO doesn't escape. If MgO escape into the air, it is going to affect the mass, which is the result, the most important result in the experiment. Okay, next. We have to lift the lid slightly from time to time. We have to open it. The reason is to allow air or oxygen to enter the crucible and react with magnesium ribbon. Lastly, why repeat heating, cooling, and weighing process until a constant mass is obtained? Sometimes, the way how they ask you this question will be the other way around. In this case, they are asking you, hey, why do we have to repeat some process? It's like repeating the experiment. You see, let's say this is the flame of the Bunsen burner. And then we have a crucible here. Okay, let's say this is the crucible. And then we are heating, okay, there's MgO inside the crucible. So after I have heated the substance for like 10 minutes, I see it no longer produce any flame. I see, okay, like no more white fumes. Okay, then I stop heating it. When I stop heating it, I let it cool down first, and then I wait. I will put it on the electronic balance. Which, to weigh the mass of the substance of the final product. And then after that, I will put it back to heating. Okay, I will heat it again. Because I doesn't know whether the mass I got just now, let's say a 5 gram, is the final result or not. I have to heat it again. Okay, after 1 minute or 2 minutes, I stop. I weigh this substance again. Maybe this time from 5 gram, it becomes 6 gram. Then I can tell, oh, just now still got 1 gram haven't reacted yet. I keep on repeating this, hitting, stop, weigh, hitting, stop, weigh, and then see. The result that I get, whether it is a constant result or not. If I get a constant mass, that means, okay, can stop already. This thing really reacted completely, can stop already. Okay, no more things that's unreacted inside the crucible. Okay, so the answer given here is to ensure the magnesium is completely burned or reacted completely. So if they ask you the other way around, guys, which is how can you make sure that the substance is reacted completely? Then you say, oh, I can repeat the heating, cooling, and weighing process until a constant mass is obtained. So this is how you make sure the magnesium is reacted completely. Okay, and then next, what will happen if the white fumes are released into the environment? That's what we said just now. It could affect the mass. Okay, so the most important precautions here are 1, 2, 3, 4, 5. These are the 5 things that you must study for MgO experiment. Okay, let's do the question at the back. Let us go through the question at the back, which is, okay, here. So let us all look at the page number 17. Page 17. So in the page 17, they told me that this diagram shows the setup of apparatus for an experiment to determine the empirical formula of magnesium oxide. Okay, so it's a crucible and direct heating. These are the results we obtained in the experiment. Crucible and the lid is 38.5 gram. Crucible lid plus magnesium ribbon is 39.7 gram. Heavier because I put in magnesium already. And finally, crucible lid plus magnesium oxide, I get a 40.5 gram. Heavier again because, okay, this one was just the crucible and lid itself, and then this one added Mg, and then there's Mg and the oxygen together, heaviest. Okay, starting with the definition. What is the meaning of molecular formula? So molecular formula is the chemical, I need you to fill in the blank, yeah, guys. Chemical formula that shows the okay, you write down the answer into your book. Okay, write down the answer into your book. This is page 17. Okay, write down the answer into your book and then tell me what to fill into the blank. The meeting is full. Really? Oh no. Okay, wait. Let me ask the admin see what he say. Ding ding ding. Okay, thanks for the answer. Let me see. Oh, some of you got the correct answer, but some of you no. Okay, guys, you see, when we are doing revision or when we are going through the questions, you have to write down things that you don't know in the red pen. Okay, trust me. When you do revision, okay, I will show you how I do it. So last time, how I do my revision or last minute study. I like to do last minute revision because I'm very lazy. So if you want to do last minute study or revision, you have to make sure you have a good material. Good material is not just a short notes or some questions with empty space. You want to read the question that you did last time and then with some useful notes written. Okay, for example, so last time, okay, I attended a seminar. And then when we are going through the question, I found out that okay, I don't know what is the word to fill in here. It's okay. That's why we are doing revision here. It's okay if you don't know or you get the wrong answer. But you have to make sure you have to write down your mistake. For example, that time I cannot answer that. Oh, it is the actual number. Then I will write it down with a red pen. So the next time when I'm coming back to this page, I will straight away see, okay, oh, the red color things are the things that I don't know. I have to memorize them. Let's say you don't know the whole sentence, then maybe you have to like, okay, put a star, okay, or highlight the question so that the next time we come back to this, you know, okay, this is something I need to study. Okay, okay. Later on, in the end, I will show the end result. So I pretend I'm a student now. So it comes to the calculation, guys. They want you to determine the empirical formula of magnesium oxide. You must know how to draw this table. Okay, so let's say I don't know how to draw the table. It's okay. I will just write draw table. So next time when I come back to this page, I see okay, oh red color, or need to draw table. Then I will focus on these things automatically. Right, guys. Since you have been given the table already, can you please help me to calculate the mass of Mg and O? Help me to calculate the mass of Mg and O. Shen Yan, what is your friend's name? Can I have her name, please? See, okay, wait, okay, mg is 0.8 gram. Thank you very much. 39.7 minus 38.5, we get 0.8 gram. Do we have the right working? Yes. You must show them the working. Show them the working. 40.5 minus of 39.7. You get sorry, what am I doing? This one 1.2. Okay, sorry. What? Sorry, okay. Sorry. This 1.2 gram, well, this one is 0.8. Okay, and then we have to calculate the number of moles. Same, we have to show them the working, guys. If you don't know, okay, if there's anything you don't know, please ask me. Like for example, I don't know how to get the 1.2. They will tell me, this is Mg and O, this is Mg, and this is the crucible and lead. I just want this thing only. I don't want the crucible and lead. Then I minus off the crucible and lead, 39.7 minus 38.5. That's how I get the 1.2. Number of mole will be 1.2 divided by the atomic mass 24. And then I will be getting 0.5. Shen Yan, the admin say there are still empty slots. So maybe she can just try a few more times, then can get in already. Something like that. I never tried before. Maybe okay. Sorry, okay, 0.8 divided by 16. Okay, 0.8 divided by 16. I'm going to get 0.5 as well. When I tekan, I got 0.05 when I tekan calculator. Okay, guys. Sorry, Sorry. Okay, 0.05. I'm not pressing the calculator. Thanks for the answer, guys. Okay, sorry. I'm sorry. Thanks for the answer. Okay, 0.05. And then the ratio. Okay, the way how we do ratio is we bring the number of mole down, and then we bring the number of mole down, and then we divide both number with the smallest one. Like in this case, both are 0.05. So I end up getting 1 and 1. So for question like this, you can actually skip the step ratio and straight away go with simplest ratio. Okay, later on we'll be doing question that's harder. Okay, and it involves different like decimal. I don't have the notes you have now. I have a different one. Why not you download it from the website? It's already there. All the notes are already uploaded to the website. You try to find the notes and see. So the empirical formula will be MGO. You got the BM version one? Why now only you tell me? It's like 20 minutes already. Okay. Continue with the next one, guys. Write the chemical equation for the reaction in the experiment. This is the experiment where we are reacting magnesium with oxygen. The product form. Okay, guys, to get the product form, we already did this in the class this week. To get the product, it's either you memorize it or you can use a shortcut. Okay, shortcut. The shortcut is like this. We list it out in the form of ion. Mg, the ion, the formula of the magnesium ion is Mg2 plus, and the formula of oxygen ion, when oxygen turns into an ion, we call it oxide ion. So O2 minus. Mg2 plus and O2 minus, when they combine, they form MgO. Is that okay? Just like that. And then we have to balance the equation. To balance the equation, it will be a 2MgO and a 2Mg. Okay. Next. Okay, Ken, if there's anything you don't know, ask me. Why was the crucible covered with the lid as soon as the magnesium started burning? Okay, they ask me, why should I cover the lid when it started burning? Okay, I give you all 30 seconds to write down the answer. We already go through the theory in front, right? I want you to try to make your own sentence. Why do you have to cover it? Because we don't want something to whoo. Okay, try to make your own sentence. Don't copy from the front. Try to write your own answer. And then if there's anything wrong, we change it with red pen later. Write the answer into your book. Thanks, Ryan. Write the answer into your book. Okay. Okay, so the answer will be we have to cover it to prevent the white fumes of magnesium oxide from escaping into the air. Okay, why is this method not suitable to determine you just wrote fumes cannot. Okay, this one, why is the method not suitable to determine the empirical formula of copper 2 oxide? This one we will do it later. Okay, we'll do it later after we discuss the next experiment. So here, they want me to explain on how to ensure that the reaction has completed. Do you still remember? How can we tell that the substance has reacted completely? We have to repeat. Okay, you help me to fill in the blank. Repeat. No need to tell me the answer. Just write it into your book. Dashini, then how you got the link and join this seminar? For sure, there is something there's a link for you to join into the seminar, right? Where you got the link? Got the link, the website, isn't it? Wait. Okay. Let me find. I also wait. Okay. Oh, you got the notes ready? Okay. Thanks. Okay. Yeah. I sent you the link also. I sent you the link also. So in case any other subject, okay, there's any other subject that you need like video, you need like notes, okay, then you can go to this website. Okay, guys, I sent it to you all also. You all can simply go Google and search TTC education, then you will be able to see like ttceducation.org. And then from there you will see our seminar post, and then from there you can get like notes, link for the meeting and also the videos. Okay. Okay. What was the answer for E? I was charging my phone. Hi, yeah. Why you charge your phone? Cannot charge phone, cannot play phone now, okay? Don't care about your phone. Let the phone die, okay? No battery is okay. Uh, we haven't write the answer yet, my dear, okay? What what if I really here's a question, okay, guys. What if I really forgot the full answer in exam? I couldn't write answer a proper, I mean like the answer they want from the book. Let's say in the textbook, they say you have to write repeat heating, cooling, and weighing process until a constant mass is obtained. If you forgot some of the keyword and you try to make your own sentence, okay, guys, very sad to say, most of the time, your answer will be wrong. It depends on your teacher, actually. Okay, some of the teacher who is kind enough, they will actually accept your answer because they know that, okay, this student actually understand what is going on. Okay, the student say repeat heating, cooling, and weighing process multiple time. Maybe they are okay with it, but guys, most of the time, no. Because in chemistry, they're very they always want to see keyword. One of the keyword is missing. Normally they will just mark it wrong. Okay, so for example, here, you must have heating, cooling, weighing process, and then constant mass octane. Only you will get marks. For example, if I say by repeat heating, cooling, and weighing process multiple time until a constant mass is obtained, then only you can get the answer and you can get the 1 mark. How many marks are 1 mark? 1 mark for this. Okay, 1 mark for this. So this is why you have to, write it down. Things that you forgot now in red pen, so you can study it, you can read it before your exam. List 2 precaution steps that must be taken during the heating process. Okay, so during the heating process, what we go through just now was we have to open the crucible lid at intervals. That means from time to time you have to open about after some time you have to open a bit. Okay. The reason is to allow oxygen to enter the crucible and react with magnesium. And then when we are doing the experiment, we also have to close the crucible lid because okay, write your own answer. Then you tell me when should we close the crucible lid. Okay, you write your answer first. You write it in your book first. Once you finish writing your answer, then only you tell me when do we have to close the lid. When heating? No. When cooling, obviously you are not listening. When cooling, you have to close the crucible lid to prevent the magnesium oxide from escaping into the air. When do you have to close it? If you don't know, if you make mistake here, it's okay. You see, you give the wrong answer, but I never mention your name one. So no one knows who's the one who said cooling. So if you gave the wrong answer, it's okay. We write it down with red pen. When magnesium starts burning. So when it starts burning, when you see the flame got fire already, then close. Then maybe like a 5 second later, you open a bit and see, got fire again, close. Then 5 second later, open, got fire again, close. Like that. Done? Okay. Guys, see so let's say the next time when I come back to this material, and then I look at this whole page, I'm like, okay, I know what to study already. Okay, you can see obviously, okay, you got like some actual number, some marking here, okay, here, and then like, okay, this is the mistake I made just last time. Okay, I don't know how to do precaution like that. Okay. Like guys, that's all for this MGO experiment. Now we have to go back to our page number 6. Okay, we go back to our page number 6. Page number 6 is the empirical formula of the copper 2 oxide. You only have one thing to do, okay? You only have one job. When we do the empirical formula experiment, we want to get the mass of copper and oxygen here in this case, okay? So the way how they carry out the experiment is not like just now, because just now the method is for, okay, anyone still remember what I said? The method just now, direct heating method is for what kind of metal? What kind of metal can use direct heating? Wailing, very good. The reactive metal, yes, Yankai, yes, very good. The reactive metal they uses direct heating. This one is for the weak. If you are strong man, you use the one just now. Okay, strong man use direct heating. If you are weak man, you use this method. Okay, so this method is for the weak man, for the weak metal. Here we write down. It's for the less reactive metal. We are not doing direct heating. We are not letting the metal burns in oxygen and then becomes oxide. We do the other way around. Okay, so it's like opposite of like the MGO experiment. We can look at the equation here. So I highlight the equation. This is the most important part, guys, you see. Just now was metal turning into metal oxide. Metal, magnesium, turns into metal oxide, MgO. That was the experiment just now. But now, it's the other way around. The other way around means it is metal oxide turning it into a metal. From CuO, it turns into Cu. Okay, you help me to write down first. This was metal oxide to metal. How? By reacting it with hydrogen gas. And then the one just now, how can metal turn into metal oxide? Add oxygen gas. Since these two experiments, they are quite similar. So in exam, they might ask you to compare the similarity and differences. Okay? What the hydrogen do here is, hydrogen is something more reactive. It is a stronger man than this metal. So what the hydrogen do is, the hydrogen will steal away the partner. It's like, hey, weak man, I'm gonna steal your girlfriend, okay? So took away the girlfriend and it forms H2O. So leaving the copper alone, can you see? Took away the oxygen from water and then copper will be alone. So this is how it works for the weak metal. Okay? Here, we also have one very important observation. During the heating process, our copper 2 oxide that is black in color will turn into brown in the end. Black to brown. I don't know whether you did this experiment in the school or not. Okay, if your school teacher did carry out this experiment with you all, it's very good because you get to see what happens during the experiment. You can see that, oh, okay, before we started to do it, it's black color, but after that, it becomes brown. Did your teacher do this experiment with you all in the school? No. Oh, you very scared lah. No, even like demo for you all to see also don't have. We only do the magnesium. You see, the school are very good one. So good until do want to like take out some material and do it, show you all. We did, but didn't get the result very good. Didn't get the result is okay. At least you can see that the thing's in black color, right? The powder. We didn't do any experiment. Which school? Belle, tell me which school. We changed. We changed to a different school. Okay, later I ask them, I help you survey, see which school did the most experiment. Then we transfer to that school. Wesley Benedict's. Ayo, why? We only did the chapter 1 experiment. I know the lousy one. Really? The one put in the water and stir, see got dissolve or not one, right? She said, what? Okay, this student said, my teacher say after exam only we do the experiment. Alamak, for what? Exam over already, and then only you do. Okay. Okay, I help you all to survey later. I tell you all which one is the best school that do a lot of experiments. Okay, then we arrange transfer tomorrow. Tomorrow, okay, we don't wait anymore. Wait no more. Okay, okay, what are the other important things in this experiment? Okay, guys, here, this one. Very important. You see, this diagram is it's a little bit more complicated than the one we did just now. There are like 3 parts, 3 sections in this set of apparatus. The middle part is the main, okay, is where the main reaction happens. Okay, main reaction happens here at the middle. Then, what is the purpose of this part where we have hydrochloric acid that reacts with zinc? This hydrochloric acid and zinc, hydrochloric acid and zinc is to produce hydrogen gas. So we need a reaction that produces hydrogen gas. Here, let's say these are the hydrogen gas. It produces hydrogen gas. And then the hydrogen gas will flow into the glass tube and have reaction with the CuO. So this is where the hydrogen comes from. Okay, this is important, very important. And then after that, another important thing is here, this one. Why do we have to do heating, cooling, and weighing process until a constant mass is obtained? Same. We want to make sure the copper 2 oxide is reacted completely. Okay. And lastly, this one. So like this box 1, 2, 3, and 4 are important. These are the common questions they ask you. So why does the hydrogen gas needs to be flow continuously for a while before the heating process is started? What they said is, before you heat the metal oxide with hydrogen gas, you have to let the hydrogen gas to flow for a few minutes. So whenever there's hydrogen gas flowing, guys, in the setup apparatus in the glass tube, you will see bubble in the final section here. Because hydrogen gas is colorless, we cannot see. I don't know whether the hydrogen gas has passed over this thing or not. Or maybe it leaks and flow out in the middle. We don't know. So if we put this thing here, we can see got bubble. Okay, if got bubble means got hydrogen gas flowing. Okay. We have to let it flow for a few minutes before we start heating the metal oxide because we want to make sure the air in the glass tube is removed. To remove the air in the glass tube. That's because mixture of oxygen and hydrogen can cause explosion. Of course, not like the very big explosion, boom, then the whole school gone. No lah. You did that. Okay, I believe you all. Okay, I don't dare to ask this question now. I wanted to say, I believe you all did this experiment, but I'm sorry. Maybe last time in the Form 2 or what, you all did a very simple experiment to test hydrogen gas with a lighted wooden splinter. When you put a lighted wooden splinter close to hydrogen gas, what will happen? It will produce a Jada, later I car bomb you, I tell you, okay. Yes, a pop sound. Yes. The pop sound is actually like a small explosion. When hydrogen gas and the oxygen gas in the air are mixed together and you light it up, it's going to cause a pop sound. So this one is the same. You doesn't want anything to pop inside the glass tube. You don't want to pop your glass tube. Okay? Can just like that. So these are the things that you have to know. And then at the bottom one, okay. At the bottom, okay, not very important. We will go through these things in the questions. So let's look at page number 16. So diagram 2 shows the apparatus setup to determine the empirical formula of oxide of copper. Okay, with this apparatus setup. What is meant by empirical formula? Oops. Okay. Same, okay, we write down first. Chemical formula that shows the Yan Kai, very good. WAILOON, very good. Shinyi, very good. Wow, very good this time. Also, you all only remember the definition for empirical formula lah, but cannot remember the molecular one just now. So the difference between this and the one just now is like, that one was actual number of atoms of each element in the compound. This one is like simplest ratio of number of atoms of each element. That means you have to change the word actual to simplest ratio of. Then the rest is the same. Okay. So you see, normally I write down the notes like this. So when I do my revision, I can do it fast. When I read this question, I get to know, okay, oh, the molecular formula one is just actual changing to simplest ratio of. Okay. Like, I want you all to do this first. C1 and C2. I want you all to tell me what is the purpose of having zinc and hydrochloric acid in this part. You write it down into your book. Okay, I give you 10 seconds. Write it down into your book. Okay, write it down in your book. Okay, so it is to produce or supply hydrogen gas. Write a chemical equation for this reaction. Zinc react with hydrochloric acid. Zinc is Zn. Which we have hydrochloric acid. Hydrochloric HCl. So to get the products, what do? We list out the ion first, the things that we're doing in this week. In this week, we have lesson now, we did a lot of questions like this. Okay, zinc, I make it Zn2 plus. Hydrochloric acid is H plus and Cl minus. So that means you have to memorize all the formula, you are right. All the charges, yes. And then it's going to form, okay, form what? This Cn2 plus, yes, it's going to steal away the girlfriend of the hydrogen. Yes, very good. Wow, you're very smart, way. Okay, plus, you all even said the same thing, okay? I also said, okay, steal the girlfriend. Okay, correct. Yes, we steal their girlfriend. So the H plus here, what is wrong with the H plus here, guys? Can we write H plus? No, never. So if you make mistake here, guys, remember, hydrogen only has two formula. Hydrogen is either H plus or H2. No other things else. Okay? There's no single H. No. If it is alone, we write H2. Hydrogen alone is H2. If it comes with a girlfriend like this, it is H plus. Okay. Wait, Chong. Hi, Chong. Morning, Chong. So what changes can be seen after the oxide of copper is heated strongly, okay, guys? Remember the color change or not? After we hit this thing, what's the color change? Yes, very good. Yes, very good. So the oxide of copper turns from a black color to brown. Dark brown cannot. Dark brown cannot. Can only be brown. Okay, black to brown. Okay, then this one, okay, thank you very much. Okay, this one is a not very important question. Okay, so I put a cross here. I said, no. This one is only important in my generation last time. Okay, how to dry the hydrogen gas? Last time, our generation, our older syllabus actually have one more extra step to dry the hydrogen gas. Okay, which is to pass the hydrogen gas over anhydrous calcium chloride. Equation haven't balanced yet. Yes, you are right. Okay, 2HCl. 2HCl. Anhydrous calcium chloride is like a drying agent. It's like the small packet, like what silica gel or something you found sometimes in the shoebox, in the bag, something like that, is to absorb the moisture. Okay, if you don't absorb the moisture, we scared it might affect the mass of the substance. It might affect the result a bit. The things that turn brown is oxide, not copper oxide powder. Okay, see, okay, see. The black color substance is actually CuO. Okay, we can write down. The black substance is actually CuO. So before we heat it is black color. After that, it turns brown. Brown is copper. Copper wire or the copper, we say bronze medal, is brown in color, right? Yeah. So it turns from CuO to Cu. So that's what I would see. When it's being heated, I see it turns black. I mean, it turns from black to brown. Okay, Bell, yes, similar to that. Similar to that. But they got a lot of different version one, okay? This one is for the chemical reaction one. Got water, got white water. The water cannot see one, okay? Like guys, this one. Determine the empirical formula of oxide of copper. So yeah, let's do it. I just want the copper. I doesn't want the combustion tube, the asbestos paper. No, so we minus it off. 147.95 minus of 135.15. Okay, this time I have to press the calculator already. 147.95 minus of 135.15. I get 12.8. Am I right? Please correct me if I'm wrong. 15 minus 147.95. Wait, really? 147.95 minus of 135.99. Wait, how come this side? Okay, okay, correct. And then the other one is 151.15 minus of 147.95, which I get 3.2. No need to write the unit. The unit is already here. Okay. So the ratio is going to be 1 and 1. So the empirical formula is CuO. Okay, then the next question, E. Copper oxide react with hydrogen. CuO is the weak man. Hydrogen, will MM be given? Yes. Relative atomic mass will be given for sure. Okay, guys, let's say since your exam is until chapter 4, right? If there's any one of the question you need relative atomic mass, but it is not given. What you can do is refer to the periodic table at the back. Your exam is only until chapter 3. For those who is until chapter 4, if your teacher is giving you the periodic table, if in the formal exam, it will be given. If I mean in SPM, periodic table, this full table will be given. But in school exam, very hard to say. My school last time, Catholic High School, PJ, my teacher never give me the periodic table before. Only until SPM, I opened the paper. Oi, how come got periodic table one? They only have found out, wow, it's our school, very cheapskate. Do you want to print the periodic table for us? So, whether you are Liu, of course, we are from the same school, bro. Of course, you're not getting the periodic table, man. So no periodic table for you. You have to ask your school teacher whether it will be given or not. Okay? So refer to the periodic table. You have to refer to the nucleon number, guys. Nucleon number is actually the relative atomic mass. For other school, if you're getting the periodic table and you need the relative atomic mass, you just refer it yourself. So CuO plus the H2, you get Cu and H2O. Just like that. Why does the hydrogen gas need to flow continuously for a while before we start? starts the heating process. This is to remove from the glass tube. Fill in the blank yourself. Okay, we say remove the air lah. Everything lah, whatever air is inside the test tube, we remove it. We just want it to be purely hydrogen inside. So can the empirical formula of magnesium oxide be determined by using the same method? Okay, now you can finally answer this question. Can the strongman use this method? Obviously, no. This method is not for the strongman. No. Why? As we say, magnesium is a strong man, right? Magnesium is more reactive than hydrogen. Meaning hydrogen cannot steal Mg girlfriend. So there's no way this thing will happen. So that's why we say this experiment is for the weak men. Weak men, their girlfriend gets stolen away. But strong men, no. Chong, right air, air for the best. The hydrogen gas is allowed to flow until the products of heating is at room temperature. That means in the cooling process, we have to make sure that the gas is still flowing. This is to prevent the air from entering the glass tube and react with the hot copper. Exam will ask 其中一个, you mean the experiment? Normally, first term exam, they ask all lah. First term exam only got like three or four chapter only. They got nothing to ask, but there are 11 questions, you know. Including the essay question, there are 11 questions. 4 chapters or maybe 3 chapters to come out 11 questions. For sure, they will ask one. Why do the heating, cooling, and weighing process need to be repeated until a constant mass is obtained? This is to ensure the oxide of copper is reacted completely. We so fast 1 hour already. Then we got enough time to do. Can. Okay. Guys, make sure you keep this material after your first term exam. The next time exam, second term exam, also you take this out. Open, read, confirm, very useful. Last minute study, best. We will learn till chapter 4, brother. In class, we already teach chapter 4, but you never come. Hiya. Joe, must have this word reacted completely. You can write copper to oxide to copper, okay, but you must have the word reacted completely. Yeah, okay, guys, just like that. Back to the question we did just now. The next page, we skip one question, right? So why is this method, they ask me? Wait. Okay, why is this method not suitable to determine the empirical formula of copper 2 oxide? Why we don't use this method for the weak man? Why don't we use this method for the weak man? Very good. Because it's weak. Okay, you see, just now, when it's about the strong one, we say, oh, because it is strong. Then this one, they ask me to comment why copper 2 oxide cannot. Copper 2 oxide cannot because weak lah. Okay, so copper is less reactive towards oxygen gas. None of the keyword here can be changed, guys. Less reactive towards oxygen gas. Last time, when I was form 4, I write copper is less reactive than oxygen gas. Then the teacher mark wrong. Cannot say then, must write towards. Okay, lor. Yeah, there's nothing, there's no way you can argue. Okay, so that's how we write it. If no right guess, right lah. Okay, right lah. Okay, finish already. Okay, finish already. Let's do some calculation question. Do you all need a break? You want to go to the toilet or get like some food? Okay, I give you all a short break, a very short one. Let's come back. Please come back at 11, 10. We're gonna do some like calculation question. Okay, which is the question that I couldn't do in my Form 4 first term exam. Okay, last time I don't know how to do, so this time I must teach you all how to do. Not done copying, copy. Come in late and then copy answer. This Chong cannot lah. And then no one knows who is Chong because in this class they cannot find Chong. There's no one called Chong. Go back to C. I'll go take a break. Come back 11:10. Can I see the diagram, bro? Your book don't have diagram, eh? Your school very special. Why your school so special? I never do. Ask your teacher do experiment lah. Keep rushing for those chapter for what? Okay. Bell, is your teacher teaching chapter 5 now? Fong, the answer is at the back of the notes. Do the tutorial question, and the answer is there. Bell, your teacher just finished empirical formula and then she told you all that exam will be until chapter 5 or 6. When is your exam? July? July? May? Not possible. Your teacher is dreaming. For sure. Last minute she will U-turn one. Based on her speed like this, May mostly can do until chapter 4 only. Chapter 4. Yeah, chapter 4. Mostly chapter 5 a bit. No way can do until chapter 6. My teacher 1 hour can speed run 2 subtopic, but can never finish experiment 1. 1 hour can speed run 2 subtopic, but do want to do experiment with your very bad. Exam until 4.4. Well, that's not possible. Not possible. You tell me end of this month whether they U-turn or not. My teacher say exam until chapter 4, but Abali is chapter 5 and 7. 5 to 7. Trust me. It will be either chapter 5 or 6. I predict it's either chapter 5 or 6. I give you 2 experiments. Okay? If it really come out, thank me. Okay, you say thank you to me later. If never come out, then okay. Just I just pretend I never said this before. If your school teacher told you that Amali is coming out experiment from chapter 5 to 6, usually from 4 chapter 5. And from 4 chapter 6, they got one very simple experiment for you all to do. One is called solubility of compounds. Okay, solubility of compounds. It is like you put the substance they gave you into water and you stir, see it dissolve or not. And then you put the same substance into something called organic solvent. Organic solvent is like hand sanitizer, alcohol, and then you stir, see it dissolve or not. But most of the time, first term exam is like 80% of the school, they do this experiment. Solubility of salt. This is actually one of the experiment that appear in the chapter 1. Okay, chapter 1 also got this experiment. It's a very simple experiment. You put the salt into water. Let's say they give you salt A, B, C. You put salt A into water, you stir. C got dissolved or not. Then repeat the experiment with salt B. Put the salt B into the water, stir, C got dissolved or not. So I think higher chance will be this one, which is the same as chapter 1. You can read chapter 1 for this. Well, later I have a survey then we change school. My school Catholic high school, very good one. Where you stay PJ Selangor. We go to okay. Okay. Then okay lah. You okay. Very sad. Move your house to Selangor, okay? Okay, like guys, okay, let's look at this one. Okay, I'm sorry. Okay, it's 11:13 already. Okay, can we look at this one? We look at this page 18, guys. Sorry, look at page 18. Look at page 18. 18. Let's do this one a bit. Okay, they show me 2 diagrams, 7.1 and 7.2. What is mean by empirical formula? Okay, guys, please write the answer yourself. I give you 30 seconds. Let's go. Okay, just like that, simplest ratio of the number of atoms of each element in the compound. This is the one of the definition that's worth memorizing for your first term exam. They like to ask this one. Suggest metal X and Y. This is for the strong man. Strong man can tahan direct heating. Give me one example of strong man. What is the example of strong man? Yes, strong man is magnesium. Okay, what are the other strong men? Other strong men can be zinc, it can be calcium, it can be aluminium, things like that. Okay, but most of the time you see magnesium or maybe calcium lah. Zinc also can. And then for the weak man is usually copper. The one we did just now, I should ask you this one. Or why not you give me another one? Other than copper, what else? What are the other metals that are also weak man? Yeah, tin, very good. Gold, well, bro, you damn rich, you use gold in this experiment, okay. Later I go your house and do this experiment, okay? Wow, silver, okay lah, can lah. Oh, you all, okay. Okay, silver can. Lead also can. So how I remember the example of metal last time is I just tell myself that, okay, weak men are those metal that usually come with Roman number. Do you remember? Like when we do chemical formula or equation, we seen things like copper 2. Wait, it's lagging. Very lag. Internet unstable. Give me a second, please. Things that come with Roman number like copper 2, something, copper 2 nitrate, copper 2 sulfate. Okay, got a Roman number 2, right? That's weak. There's a symbol of weak man. Roman number. Lead 2. Tin 2. Or even iron 2. Iron is also a weak man. Okay. Wait, I wrote something, but it never appeared. Potassium is a strong man, okay? Potassium is strong. No Roman number is usually strong. Yes, all the 2 is weak man. So the next week, I'm going to call you Chong 2 because you are a weak man. But guys, I don't know. Sodium is strong also. Sodium is strong. Okay. My screen is lagging. I don't know why. Suddenly the internet become unstable. Okay, you all write down the answer already, right? Okay, now we write the explanation. We write the explanation. I will tell you the explanation, they will write down. They ask me, like X. Give me an example. I say magnesium. They ask me why magnesium. Okay, they ask me why magnesium. Our reason will be, okay, why magnesium is suitable for experiment 1. The answer is magnesium is reactive. Or you can say magnesium is more reactive towards oxygen gas. Can I guys write down for X? Magnesium is more reactive towards oxygen gas. Metal X is more reactive towards oxygen gas. And then when they ask me why, metal Y, use the second method. The reason will be copper or the metal Y is less reactive than hydrogen gas. Wow, cannot wait. I think need to reconnect already. Okay. Shit lah. Okay, I'm back. Okay. Okay, let's continue, guys. Okay, the answer I typed into the chat box already. What does mean by what does the weak man means? I drink water to calm myself down first. Hey. Weak man means the metal very weak, no reaction. When you hit it, nothing happen. Okay, like iron, stainless steel, you hit it, they just become hot. They will never burn. That is called weak. Okay, right, guys, here we have two sets of experiment. So they want me to compare the two methods. Let's compare. Okay, so guys, do you remember the first experiment just now I told you all? This is for this is okay. Let's say mg. So I told you all that this experiment, they are actually terbalik, right? This experiment is turning from something into something. Can you please tell me what is the something and something here? I gave you this important note when we go through the experiment in front just now. We said this experiment is Yankai very good. It's always from a metal to metal oxide. Very good. So in this case, okay, I write down the first thing. So we talk about the product first. Metal oxide is formed in this experiment. Okay. Then the other way around. Okay, I write down. I just write out the equation lah. I didn't balance the equation because for this case, balance or no balance, it doesn't matter. We just need equation to see the information only. So it produces a metal oxide. But this one, a metal is formed. So the easiest way to do this comparison question, let's say it is coming out in like essay, compare 6 marks, very easy one. The format, the formula is like you talk about product, then you talk about reactant. You see the reactant here. This one is reacting with oxygen gas. This one is reacting with hydrogen gas. So we say for this set one, metal reacts with oxygen gas. Chemistry essay question looks like this, like this, just like this. It is not like writing karangan. It's not like writing karangan. It is just like a longer question. You just answered it normally. Okay, and then this one is metal oxide reacts with hydrogen gas. Can draw table? Can draw table. AC is just a term to describe a long question. You just answered it normally, like normal structure question. You can draw table also can. No specific format one. As long as you don't do point form, never do point form. Point form is like you put a bullet and then answer, bullet, answer, never. That one is the last question where they want you to write the procedure of the experiment. Okay, so in the end, okay, guys, what happened here is for the set one, the mass of the solid increases. From metal to metal oxide, the mass of the the substance will increase. So before I do the experiment, after the experiment, the mass will be higher. And then this one, the mass of the solid decreases. This is the difference in terms of method. Okay. Can I change solid to metal? Cannot. Because you see, one experiment is metal. Another experiment is metal oxide. So just write solid. That you use a general term. Lin Feng, any question can come out. Only got 3 chapters. Study all of course. Everything also can come out. Everything also will come out. You only got 3 chapters. Okay, guys. Let's go to the page number 25. So this is the question that came out in my Form 4 first term exam, which is like 15 years ago, maybe. Okay. Guys. But every year, I will don't call people uncle, but I will still do this question every year with my student because I cannot take it. Last time I don't know how to do. I cannot take it. Cannot. So I want you to know how to do this one. Don't be like me. I want you to be a strong man, not like a weak man. So they told me that the hydrocarbon X, you saw this on my YouTube. Hydrocarbon X contains 85.7% of carbon. And then according to the mass, 5.6 grams of hydrocarbon occupies a volume of 4.48 dmq at STP. They want me to determine the empirical formula of X. My friend cannot enter into this room because it is limited, full already. Your friend just want to come in now. Our class is ending already, you know. You tell you, you ask your friend go. Or since earlier this time, how I also don't know leh. Our friend just now wait let me see Xuan Yin, your friend managed to come into this class, managed to join this class just now. Xuan Yin, can or not? Just now Xuan Yin's friend also trying to come in but cannot. Xuan Yin, she also missing already. Okay, like to do this question, my friend cannot join also. She didn't reply me, so I'm not sure. I think not here, okay? I don't know what's wrong with this thing. Maybe too many breakout rooms already. Maybe too many participants in this meeting already. I think there's a limit, maybe like 1,000 or maybe 500, something like that. Okay. So like here, to do empirical formula, first starts with element. To know what are the elements, you can just look at the relative atomic mass. So when last time I'm a weak man, I don't know. I don't know this. I simply temp out from the question, but I can actually look at the relative atomic mass to get the element. Hydrocarbon means it is a combination of hydrogen and carbon. Okay, so I write carbon first and then I write hydrogen. If you put hydrogen in front, also can. But the schema will be prepared with carbon in front because this is something that you will be learning in the Form 5. So now, if you put hydrogen in front, your teacher can actually accept it. The next thing you have to do is the mass of carbon and hydrogen. Okay, guys? To test whether you are a strong man or weak man like me last time, tell me, What is the mass of carbon, like guys? Based on the information given here, what is the mass of the carbon? What is the mass of carbon? What is the mass of carbon? Liu, faster give me answer, Liu. You big man. Liu, what's... Okay. How you... Okay. So I see, let's see any one of you got the same answer. Why no one get the same answer like me last time? Okay, guys, you see, when we do empirical formula, yes, I finally see one answer that's same as mine last time. What I do is, I know I need the mass of carbon and hydrogen. So I look at this thing like, oh, okay. This hydrocarbon is 5.6 grams. Carbon is 85.7%. So I goes like 5.6 times 85.7 divided by 100 to get the mass. And I get 4.8. Whew. Like that. In the end, wrong. The teacher say, no need. This is not needed. Not needed. You should just use the percentage directly as mass. So this is something very important. I must put a star here and remind you all. Percentage is mass in empirical formula. So whenever you have been given a percentage in empirical formula calculation, just put it in as mass. 85.7%. Yes, the hydrogen will be 100 minus off. Why? So many strong men here in this class. 14.3. Okay, then later on, we have to calculate the number of moles. The number of moles of atom. I write number of moles also can lah. Okay, 85.7 divided by 12. Help me to press the calculator, thanks. 14 divided by 3. 14.3 divided by 1. I get 14.3. Okay. 7 must write 3 decimal places. 7.142. 142. 3 decimal places. And then next, our ratio. Mole ratio. 7.142. Bring it down. The other one also bring it down. Divide by the smaller number, 7.142. 7.142. Your teacher say needs 4 decimal places. Can also at least 3 decimal places. Usually we take 3 lah. It will give more like 4 decimal places. Okay. Can. Well, your teacher too pattern already lah. Too much pattern lah. Okay. This one we get 2.002. We can actually just make it this one simplest ratio. Okay, we should make it simplest ratio. Since I can already get whole number 1 to 2. So there's no need to do ratio and then simplest ratio again. Okay, we straight away do the simplest ratio can already. So in full, it will be simplest mole ratio of atom. If you want to write it in full, it is simplest mole ratio of atoms. Of atom, like that. So the empirical formula will be equal to CH2. Okay, and then next. Everything okay, right? Determine the relative molecular mass of X. So to determine the relative molecular mass of X, relative mass is actually the same as molar mass. So I have already used this information to calculate the empirical formula. Now I have to use the 5.6 gram and also the 4.48 dm cube for this question. So in order to get the relative molecular mass or the so-called molar mass, I will need to use this formula. Mole equals to mass over molar mass. In chemistry, when you don't know how to start or solve a calculation question, just ask yourself, the question or the information given to me can be sub into which formula? Because we only got 3 formula. Mole equals to mass over molar mass, mole equals to volume over molar volume, and also mole equals to number of particles over the Avogadro's constant. So in this case, they want me to find molecular mass, which is the molar mass. For sure, I would need to use this formula. Now you check the question and see. Do you have mole or mass of this hydrocarbon? Oh, I found it. I got the mass. So I put it in first, 5.6. Okay, divided by the molar mass. I don't know what's the mole. I don't know what's the mole. I don't have the mole. The mole here is for carbon and hydrogen. Hydrocarbon, the combination, don't know. But it's okay. I still got volume here. Whenever you have been given a volume, you have to use mole equals to volume over molar volume. So let me sub it in. 4.48 dm cube divided by the molar volume. What's the molar volume? They say 22.4 as STP. 22.4 at STP. Then I will be able to find mole. Can you see? It's like, I'm not even thinking like, what the question trying to say. No, you just put the number they gave you into the correct formula. And then after you've done the first step, you realize, oh, okay, then I just put this mole into this empty space and automatically you will get the answer. Like guys, I want to test whether your mathematics is good or bad. Please tell me what is the answer here. If you don't know how to do this, you must, your math teacher must be a sejarah teacher also. Guys, for those who got 11.2, you learn your mathematics from your sejarah teacher. Come on, it's 28. Guys, you move this thing here. You move this thing here is divide. Divide, not times. Go to the mathematics class now. Divide. If the 5.6 is at the bottom, then you move there, that one is times. Like let's say like this, then this one is times. My God, okay. It's okay. Now you know. Okay. I put a star, y'all. This one, if you do know how to do this, you put a star. Okay, then guys, what's the unit? What's the unit for molar mass? How to get 28? 5.6 divide 0.2. Divide. You move it here means divide. Aish. Okay. The unit for molar mass is gram per mole. Very good. Very good. It's gram per mole. But you can't leave this as your final answer, guys, because they want the relative molecular mass. We said relative molecular mass is the same as molar mass, yeah? But you have to write it out like this and show them relative molecular mass of X is 28. Okay, what is the unit for relative molecular mass, guys? Shinji, very good. I clap for you. Wow. Jaden, very good. Chloe, very good. Wow. That says no unit. Very good. Relative mass should never have any unit. No unit. Okay, so that's the difference. Molar mass and relative mass. Finally, molecular formula of X. So for molecular formula of X, this is how we do it. We already have the empirical formula, the simplest ratio. We can times a number into this empirical formula to get back the actual formula. Okay, so let's sub all the information into this formula. We found that the empirical formula is CH2. Need to times a number. We don't know what's the number. And get back the molecular formula with the mass of 28. Sub all the info in. 12 plus 1 times 2. N equals to 2. So times it in. If you times 2, you're going to get C2H4. You can always double check your answer by putting in the mass of carbon and hydrogen, see it is equals to 28 or not. One question like this is 7 to 8 marks. One whole question like this, 7 to 8 marks. If you can't get this part correct, most likely you won't be able to get the answer in the following question as well. I don't understand how you find that N equals to 2. My dear, stop learning mathematics from your sejarah teacher. Okay, see Okay, this one is carbon. Carbon is 12, right? Hydrogen is 1 times 2. Correct? So what's the total? What's the total? Total is 14. Total is 14. 14, N equals to 28. N equals to 2. Okay. You get it? The 12 and 1 understand the okay, yeah, okay, yes, okay. Like guys. Now let us go to the page number. Yeah. Page number 28. Where is the one? Wait. Okay, can we look at this page number 28? This is one of their favorite exam question, okay, which is talking about airbag. So they told you that the airbag contains a solid sodium azide, NaN3, that decomposes rapidly into sodium metal and nitrogen gas when the car kaboom. So the nitrogen gas produced will fill up and expand the airbags. Write the chemical equation for the decomposition of this substance. So you just write it down. It is given. If there's something special, they will give you the formula. Wait, what am I doing? Decompose means break down. So straight away, arrow. They told you that it produces sodium metal and also nitrogen gas. Sodium, nitrogen gas. Okay, then we have to balance the equation. How do you balance? Can I have the numbers to balance this equation, please? What are the numbers that will be used to balance this equation? Very good. It's a 2, 2, 3. Thanks. 2, 2, 3. Correct. Very good. Right, next. Okay, before we do the calculation question, in exam, first term exam, 80% of the time, they will ask you to do something. Okay, describe. It's like last time, when you all were kid, you always ask your friend, can you DESE me? Something like that. So you have to describe. You all like to describe, right? Now you describe the equation. Describe the equation qualitatively and also quantitatively. Or sometimes they will change the question a bit lah. Describe the equation in a quantitative or qualitative form, or give information related to quantitative and qualitative. Okay, this is how you do this question, guys. When you want to interpret or describe an equation, interpret the equation, same as interpret. When you want to interpret the equation, qualitative and quantitative, you have to look at the equation. That means you have to make sure your equation is correct. Then only you will be able to do this. Like this. For quali, I always do the quali first. For qualitative information, you actually have to tell them what are the reactants and product in the reaction. So what are the substance used in the experiment? You can see, they told you in the question, right? So the answer is like this. So the solid sodium azide is reactant. Wow. The sodium metal and nitrogen gas are products. So this is the meaning of qualitative information. It's like, hey, based on the equation, what are the reactants, what are the products? Qualitative. Reactant and product, okay. And then for quantitative, in terms of quantitative, oops, oh no, no. Quantitative, so quantitative is like quantity. Quantity, you have to tell me the number of moles. So that's the difference. You see, you did put in some number to balance the equation just now, right? So you have to tell me those number. This is how you write the answer. 2 moles of, so 2 moles of the sodium azide decomposed to form, or you can say decomposes into 2 mole of sodium metal and 3 moles of nitrogen gas. So this qualitative and quantitative. Okay, very important for your first term exam. Very important. Quantity, done. Okay, there's a very similar question in the next page, you see. Like here they say, state two qualitative and quantitative information. So you just tell them the reactant product, and then you make a sentence by telling them all the numbers. Okay. Jaden, a very good question here. So when we are writing the qualitative and quantitative information, we try to involve the state of the substance, like solid, liquid, or gas. If it is not given, do we have to write it? The answer is, if you know what is the state, you write. If you really don't know, don't try your luck. For example, if let's say I'm doing this question, I can only tell that this is a gas, but the rest I don't know. I don't know whether this is a liquid or solid. If you never write the state, sometimes your teacher are actually okay with that. If you say 2 mole of sodium azide decomposed into 2 mole of sodium and 3 mole of nitrogen gas. This one I know I say gas. The 2 I don't know. You don't write the state, it's actually okay one. But if you give the wrong state, you will say 2 mole of liquid sodium, straight away 0 mark. Because in chemistry, we have something called wrong answer right. Wrong answer right means wrong answer, automatically -1 mark. Even though maybe the part at the back is correct, they don't care. Wrong is wrong. One small mistake, everything wrong. Okay, can the answer depends on what comes first on the question. The question, which one? The answer is based on the equation. Okay, like this one, okay, guys. Now, like this one, you see, they told you that it's liquid propanol. So I will say liquid propanol and oxygen gas are reactant. Carbon dioxide gas and water are products. So quantitative, in terms of quantitative, 2 mole of propanol reacts with 9 mole of oxygen gas to produce 6 mole of carbon dioxide gas and 8 moles of water, like that. Okay, so I just want you all to remember these 2 terms. After that, here, question B is also one of the questions for sure will be coming out. Favorite question. Every exam also got this kind of question one. So see what they do. What they want you to do. If the volume of a normal airbag is 57.6 dm3, calculate the mass of sodium azide that has to be in each airbag. They gave you the volume of gas needed to inflate the airbags. Okay. And then they want you to find the mass. So it is like they're asking you, hey, we need 57.6 dm3 of gas to fill up the airbag. So how many grams of this substance is needed to produce this amount of gas? Can you see? It involves 2 different substances. I gave you A, but I want you to find B. This is different from what we did just now. Later on, if you try the question in front yourself, like this kind of question, they ask you to determine the mass of something, the number of molecules. They are all within the same substance. They show you vitamin A. This is called vitamin A. Then they ask you everything about A. Like A, what's the mass of A? What's the mole of A? What's the molecule of A? Only involve one substance. But this one, it involves more than one substance, then you must do ratio. One extra step. As long as it involves different substances, you must do ratio. Like guys, this is what I will normally do. They want me to find the mass of, I will always write down mass of what they want me to find. NaN3. I write it in formula form. That's what they say. And then the information they gave me is 57.6 dm cubed of N2. In the middle, I do ratio because these are two different substances. Once you write all these things down already, then you should be able to know how to start to solve this question, starting from the value given. In chemistry, you only got one thing to do, calculate number of mole. So mole is equals to 57.6 divided by molar volume, 24. So I get 2.4. Okay, to do the ratio, the number in front of the N2 is 3. So I write 3 mole. NaN3 is a 2, so I write 2 mole. Then you bring the number that you calculated down here, 2.4 mole. If the ratio is 3 to 2, 2.4 is to, can I have the answer, please? Wow, 1.6, very good. Yo. Okay. Those students who learn their mathematics from the sejarah teacher, this is how you get 1.6. Let's say this number is, okay, this value is x. To find x, this is what my primary school teacher taught me. When you are doing ratio, you want to find one of the unknown, you do cross multiplication. It's like you put two lines, you do cross multiplication. Then you sure can get the answer one. For example, x times 3, you get 3x. 2.4 times 2, you get 4.8. To find the x, you move the 3 to the other side. 4.8 divided by 3. Oh, 1.6. This is the best method ever for ratio. Okay, finally, 1.6 mole is equals to mass over molar mass. Na and 3. We get 104 gram. Xinyi, yes, you are right. Okay, yeah, there's more than one method to get the ratio, but my favorite one is the cross multiplication. If you have your own method, then you use your own method. It's okay one. Okay, guys. A question like this 3 marks. And then before you do the calculation, they would ask you to do chemical equation. Chemical equation is 2 marks. So one package like this is 5 marks. Okay, just like that. The one at the bottom. Oh my god, walao, this one where got time to do this one? Okay, like guys, still have to do okay, like it's not a very common question, but it's okay. Let's do this. C2H6O with oxygen, they say, produces carbon dioxide and water. To balance the equation, 2 carbon, 2 CO2, 6 hydrogen, 3 H2O, 2 times 2, 4, 3 times 1, 3, 7 O in total. Minus of the 1 O here, I still need 6 here. 6 and 1, 7, so 3 off. 3, 2, 3. 2 marks by doing this. Okay, 2.76 gram of ethanol reacts with 6 dmq of oxygen gas in excess. In excess means this is not the real number. You don't need this much of oxygen gas. 6 is already more than what is needed. So that's why the question asks you to find unreacted oxygen gas. So you see, this is not the actual number. I want to find out what is the actual number. So this is what I do, guys. They gave me 2.76 gram of ethanol, the C2H6O. This is what they gave me. And now I'm trying to find the oxygen gas. Okay, volume of oxygen gas. There are 2 different substances, can you see? So I have to do ratio. So I do one by one. Starting from this, mole equals to mass over molar mass. C2H6O. We get 0.06 mole. The ratio, bring it down, 1 to 3. 1 mole is to 3 mole. Oh, by the way, if your school teacher wants you to write the ratio in sentence form, then you all have to write the sentence form. Sentence form is the one you all should know one. The one you have to keep on writing from the equation. From the equation, 1 mole of ethanol produces 3 mole of oxygen, something like that. So in this case, it will be 1 mole of ethanol reacts with 3 mole of O2. And therefore, I bring the number down. 0.06 mole is equals to 0.18 mole. So this is the amount of oxygen that will be reacting. So I use 0.18 mole equals to volume over molar volume 24. I'm going to get 4.32 dm3. So this is the amount of oxygen that will be used. This is the real number. The one they gave me, fake value. So how much is unreacted? 6 minus of 4.32. We get 1.68 dm3. So 1 mark, 2 mark, 3 mark, 4 marks, 5 marks, 6 marks. Okay. So the way of doing unreacted question is, first, you ignore the value given. Okay? Unreacted means you ignore the value given at first. And then only use it to minus the amount you found to get unreacted. Okay? Can Must ignore first. Don't use the value first for unreacted question because that one is fake value. Okay. Can I have another 5 minutes? I still got one more important question to go through with you all. Okay. OT 30 minutes. Okay. Like we look at page number, this one. Where is it? Give me a second. Yeah. Okay. 11, page 11. Page 11. Okay, let us look at this question at the bottom. Here, starting from the table here. They gave me 3 substances, PQR. Suggest the physical state. For this kind of question whereby they give you melting and boiling point and want you to tell the physical state, we always do it like this. Do it like this. This is what I do. Melting point. Melting means at this temperature, it's going to turn from solid to liquid. And then when it comes to boiling point, the liquid is going to turn into gas. So I want to know, with the temperature they mentioned here, room temperature, 25 degrees Celsius. You write 27 also can, whatever. It doesn't matter. You write 24 also can. Around there, okay, 25 somewhere there. Then you ask yourself, at room temperature, which is 25 degrees Celsius, is this temperature higher than the melting point? Oh, yes. Is this temperature higher than negative 89 boiling point? Oh, yes. Then I put it here. I put it into range. So here, gas. So P is gas. And then you repeat the same thing. This 25 is bigger than 15, but smaller than 17. So it is a liquid. And finally, this one, 25 is smaller than melting point. So it still exists as a solid. That means this temperature is not enough to melt the substance R yet. So it's still a solid. All right, the easiest way. Here comes the one that I want to go through. In the first example, also for sure, there will be questions like this. Boron exists naturally as 2 isotopes, which are 19.9% of boron 10 and 80.1% of boron B. Boron 11. Calculate the relative atomic mass. This is called, this information given is called the natural abundance of isotopes. Okay, natural abundance of the isotopes. When you see this package, percentage of isotope, relative atomic mass, all you have to do is use the 19.9% to times 10. 10 is the nuclear number. Nuclear number is the same as relative atomic mass. Just times it. Plus 80.1 times 11. And then divide by total. 100. The answer is, can I have the answer, please? How much is the answer? What's the answer? Negative. Negative 10.8. Normally write 2 decimal place. But the one last number at the back is 1. So you just write 10.80 or 10.8 is enough. But if you ask me, what if I write more? 801 actually also can. It doesn't matter. Okay? At least 10.8. This is what I want to do, guys. This one very easy. This one very easy. But now here, sulfur has two main isotopes. Sulfur 32 and sulfur 34. And shows that the relative atomic mass is 32.1. What is the abundance of both isotopes? So what is the percentage? Oh my God. You see, now if I want to do 32, I don't know times what, plus 34, I don't know times what. They never tell me. But I know the final answer is going to be 32.1. So how, guys? Put X. Okay. I put X here. Then how about here? How about here? Which means sulfur 32. Okay, sulfur 32, I don't know how many percent. So you all suggest me to put X%. Okay. How about the sulfur 34? How about sulfur 34? Oh, Jaden. Very good. Oh. Xinyi, what should we put here? What's the unknown? Beatrix, very good. So king one your way. Xinyi, what's the unknown? Okay, here, we cannot put X, guys. Takkan both also X, but both also X means their percentage is the same, percentage supposed to be different, right? Here, cannot put Y also. Cannot put Y. You should put 100 minus X. If you have found that this is, let's say, 20%, then this one you just use 100 to minus 20%, you get the answer. Okay, so this is what you have to do. 34 times 100 minus X. So 32X plus 3,400 minus 34X divide by 100 equals to 32.1. So I move the 100 to this side and make it 3,210. Okay, I already moved the 100 over to the other side. Then just solve the remaining one like the mathematics. 32X minus 34X is negative 2X. Move this thing to the other side. You get a negative 190. So in the end, X is equals to 95. 95 lor. So sulfur 32 is 95%. Then how about sulfur 34? You use 100 to minus the X, minus the 95 lor. So it will be 5%. Like that. Okay, so this is why I said in the beginning of the class, we do revision is to find out what are the questions that we still don't know how to do. Okay, so I hope you learned something today. And yeah, that's all for today's lesson. And thanks for joining the class. And thanks for giving me answer and response, guys. Thank you very much. I'm going to sleep already. Okay, bye-bye. If you have any question, you can either WhatsApp me if you have my number, you WhatsApp me. You want Insta PM me also can. That's all. Can explain again. Which one? If no question, then bye-bye. See you guys. Bye-bye. See you next time. Bye-bye. Bye-bye. Thank you very much. Bye-bye. Don't understand the percentage part. Which one? This one? This one can understand or not? Bye, Chong. Xuan, this one can understand or not? Can, okay. Then here, same. You see, because we doesn't know what is the percentage. They want us to find the percentage, right? Beatrix, good luck. Okay, I pray for you. Since the Amali so easy already, hopefully the paper 2 is a bit harder. Okay, Shannon, you see, I don't know what's the percentage one, right? In mathematics, when we do know something, we put unknown, correct or not? We put X, oh, right? X percent ma. Here, you cannot put Y. If you put Y, if you put Y, then you will have two unknown. Two unknown cannot solve one. So what we do is we use 100 minus X because percentage ma. Percentage total is 100. If I found the answer is 80, then here I just use 100 minus 80, I get 20. Oh. Understand or not? Okay, just like that. Why 25? That one is the temperature of room temperature. That one is room temperature. 小偷啊，我踢你两脚飞掉啊。Room temperature 室温 in the syllabus is 25 degrees Celsius。不然是多少度？你跟我讲。OK，bye 玄燕，see you。Okay，bye guys，bye Liu。Good luck in preparing your midterm exam, guys. Bye bye. Bye bye. Bye bye.